Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today is our second lecture of chemistry. The chapter name is Fundamentals of Chemistry and the topic name is Atomic Mass, Mass Number, Relative Atomic Mass Unit and the chemical formula and its types. First of all, what is atomic number? The atomic number of an element is the number of protons or the number of electrons present in the atom in the nucleus of one atom of that element. Atomic number is represented by Z. It means that we can say that in atomic number of protons are equal to the number of electrons. For hydrogen, the atomic number is 1. Similarly, for carbon, the atomic number, that is, the number of protons or the number of electrons, are 6. For sodium, the atomic number or the number of protons are 11. The atomic number counts the number of protons in an atom. Likewise, this is an example of sodium. The 11 is the number of protons or the number of electrons of sodium. An atom is electrically neutral because it has the same number of protons and the same number of electrons. As we know that protons have positive charge and electrons have negative charge. When we have equal number of positive and negative charges, they will cancel the effect of each other and the net charge will be 0. So we can say that the atomic number is equal to the number of electrons or the number of protons. Second is the mass number. Mass number is also called as nucleon number. Mass number counts the number of protons and neutrons in an atom. As proton and neutrons are relatively heavier particles than electron, so mass of an atom depends upon the number of protons and neutrons present in the nucleus. Mass number is represented by A. This is an example of the mass number. For carbon, as we know that number of protons are 6. But mass number is the sum of number of protons and the number of neutrons. So 6 are the number of protons and the remaining 6 are the number of neutrons in the atomic mass. Atomic symbols. It shows the mass number and atomic number. We take an atom, that is sodium. Its atomic number is 11 and its mass number is 23. Similarly, take an example of oxygen. Oxygen has atomic number of 8 and mass number of 16. Carbon has a mass number of 6, atomic number of 6 and mass number of 12. Nitrogen has atomic number of 7 and mass number of 14. These are the examples of atomic masses and atomic numbers. Oxygen has atomic number of 8 and the mass number of 16. As we know that 8 or atomic number or the number of protons or the number of electrons. 8 are the number of protons or the number of electrons, whereas 16 represent 8 number of protons while the 8 number of neutrons. In phosphorus, 15 are the number of electrons or protons, and in the mass number, same 15 are the number of protons and the remaining 16 are the number of neutrons. Now for zinc, the atomic number of zinc is 30. It means that the number of protons or the number of electrons are 30 and the remaining are the number of neutrons. Here is an example of uranium. The uranium has the atomic number 92 and the mass number 235. We had taken the isotope of uranium which has mass 238 and atomic number 92. It means that the number of protons or the number of electrons are 92 while the remaining are the number of neutrons. We can calculate the number of neutrons by subtracting number of protons and neutrons with number of protons. Now, this is the relative atomic mass. The relative atomic mass of an element is the mass of an atom of an element relative to the mass of 1 by 12 parts the mass of carbon 12. The carbon is taken as standard for measuring the masses. If we measure the mass of an atom in grams or kilograms, it has been a very small value that we cannot measure the masses easily. Measuring such a small masses are not only impossible but are also impractical to work with. For that purpose, atomic masses are expressed by comparing with the mass of standard atom. For example, we have taken a standard atom called as carbon. The atom chosen nowadays as the standard for comparison is that of carbon 12, which has a mass of exactly 12 units. This is the relative atomic mass for carbon. Here is a term used known as atomic mass unit. According to the atomic mass unit, as we know that average weight of carbon 12 is 12 gram, which is equal to the 1 mole. And when we are relating mole with the Avogadro numbers, then we come to know that 1 mole of carbon 12 contained atoms is equal to 6.023 into 10 raised to power 23. 1 carbon 12 means 1 mole. When I have mass of 24 relating to carbon, that I will say that carbon contains 2 moles. So, according to the atomic mass unit, 1 atom of carbon 12 is equal to the atomic weight of carbon, that is 12, divided by Avogadro number 6.023 into 10 raised to power 23. And the atomic mass unit in grams of carbon is 1.992 into 10 raised to power minus 23. When we consider the mass of carbon in grams, we will divide 12 with 6.023 into 10 raised to power 23, and we will get 1.992 into 10 raised to power minus 23 grams. But when we are taking a standard and we have to represent the carbon in atomic mass unit, in atomic mass unit I have said that we will take 1 by 12 the mass of the carbon. Now we will take the 1 by 12 multiply the mass which we have already defined from atomic mass unit in grams, which is 1.992 into 10 raised to power minus 23, and the result will be 1.67 into 10 raised to power minus 24 grams. But if we want to represent in kilograms, then it will be 1.67 into 10 raised to power minus 27. The sodium has a relative atomic mass of 23 AMU. It means when the atomic mass of sodium is 23, it is equal to 1 mole. Oxygen has a relative atomic mass of 16. So when atomic mass of oxygen is 16, it is equal to 1 mole, and 1 mole is equal to 6.02 into 10 raised to power minus 23 Avogadro number. Here is the detail about relative atomic mass. The mass of an atom when compared to another is known as the relative atomic mass. The relative atomic mass of an element is the average mass of one atom of an element, that is carbon, the mass of carbon, which is 12, when compared with 1/12 of the mass of an atom of carbon 12. We are taking mass of one atom of an element by 1/12 of the mass of one carbon 12 atom. 1 by 12 of the mass of an atom of carbon 12 is named as 1 atomic mass unit. The mass of one carbon atom is 12 AMU, as its atomic number is 6 and atomic mass is 12. So 1 by 12 of the mass of an atom of carbon 12 is named as 1 atomic mass unit. The mass of one carbon atom is 12. Relative atomic mass of an element is mass of one atom of the element by 1 by 12 of the mass of one carbon 12 atom. For example, the mass of a sodium atom is 23. we are taking the mass of one atom of an element, which is sodium, and the mass of sodium is 23, which is the greater than 1 by 12 of the mass of carbon 12 atom. What is the relative atomic mass of sodium? Then the answer is 23. Now this is another term, average atomic mass. The average atomic mass is the weighted average of the atomic masses of the naturally occurring isotope of an element. For example, the average atomic mass is equal to atomic mass of first isotope multiply its percentage abundance. In the numericals, you will have given the percentage abundance and the total parts. Here I have 100 parts, so I will divide it with 100. If I have 10 parts, I will divide it with 10. So the